Okay, so a proportional constant is just a technical word for the ratio or the value of how two quantities relate. They're just putting a numerical value to it. So when I made the video about what is a proportional relationship, I used two quantities, squares to triangles. So in this case, we have a proportional relationship. For every one square, there were 3 triangles. And the proportional constant is just that numerical value, that number value that tells you this relationship. So in this case, the proportional constant was the fact that we had what was consistent, what was constant, what was not changing, was the fact that we had 3 triangles for every 1 square. So that ratio was we had 3 triangles for every 1 square. 3 of these triangle pieces. I'm trying to draw a triangle right now. Forgive me. All right, that's horrible. Sorry to put you through that. We had 3 triangles for every 1 square. So the proportional constant is the name for what that ratio simplifies to. And in this case, that proportional constant is 3. Here, to look at this relationship, we can break it down even more. We try to figure out what it is per group. It looks like from the last example, we had for every 2 circles, we had 3 of the parallelograms. So in this case, it looks like we almost have our proportional constant. We want to say there has a ratio of, in this case, 2 to 3. For every 2 circles, you've got 3 parallelograms. So how do we find the proportional constant in this case? So what we're going to do is, because we don't have a single unit to compare, we're going to have to do some work. A proportional constant, if I consider these to be this x quantity and this to be the y quantity, I want to know the proportional constant. I'm going to shrink these down here, move some pieces around, give me some room to work. If I want to know the proportional constant, I'm going to use PC to represent that. The proportional constant of parallelograms to circles. Since I want parallelograms to circles, that's going to mean that the parallelograms become my x quantity and circles are going to be my y quantity. So I notice that we've got 3 parallelograms for every 2 circles. So we can find the proportional constant by doing some division. And in this case, we would do 3 divided by 2, which is 1.5. Which means that for every 1 circle, we are going to have 1.5 parallelograms. Which means we would cut this sucker right in half. And that's how many parallelograms there would be. We'd only have 1.5 of these parallelogram pieces. So let me just highlight that. Well, notice that half a parallelogram is a triangle. But there we go. So for every 1 circle, we've got 1.5 parallelograms. So in this case, our proportional constant turns out to be 1.5, or 3/2. So that's what it is. It's the number that helps you realize the connection between one kind of quantity to the other quantity it's being compared to.